Welcome to my video on writing an equation from a verbal description. So the slope is the rate of change applied to the independent variable. So you'll see that in front of the letter that represents the independent variable. The y-intercept is the starting value added to or subtracted, and we need to add the word from here, subtracted from the slope. And the independent variable, remember, is the input or the x value, and the dependent variable is the output or the y value. Okay, so let's look at some examples. Okay, Luke has a cell phone that costs $22.50 per month and 5 cents per minute. How much will Luke's bill be if he uses 30 minutes, 45 minutes, 1 hour? So what we need to figure out here is, what do we want to know? We want to know how much his bill is, correct? So the bill is going to be what the equation equals. So that's going to represent the dependent variables, so the bill. And we're going to use B for bill, okay? But this would also represent the y value. If y equals mx plus b, the b is going to stand for the y. Okay, the independent variable is going to be our minutes, because that's what we're going to be plugging in. So we're going to write our independent variable is our minutes. And we're going to use m for minutes, but that's going to stand for the x. Okay, so now let's write our equation. Okay, we are going to write the bill. So we're going to write B equals, and it costs $22.50 per month and uses 5 cents per minute. So we're going to take the 5 cents, because we're trying to write it in y equals mx plus b. We're going to take the 5 cents, which is going to represent the slope or the rate of change, and we're going to multiply it by m, which is representing the minutes. And then we have a fixed cost of $22.50. So that's going to be our y-intercept. That's going to be our constant. Okay, so our slope is going to be 5 cents. And our y-intercept is going to be that $22.50, that constant. Okay? Now, I know the way it's written is $22.50 plus 5 cents per minute. But I'm writing it like this to keep it in y equals mx plus b form. And we can write that under here, because now you can see that it looks like y equals mx plus b. So that's the only reason I didn't write $22.50 plus 5 cents out. Okay, now we're going to use that equation to represent the 30 minutes, 45 minutes, and 1 hour. So we have our input is our minutes, and our output is going to be what we get, what the equation equals after we put in the input. And our rule is 5 cents m plus $22.50. Okay, so we're going to take our first input, which was 30 minutes, and we're going to take 30 times 5 cents, which is going to give us a, oops, hold on, let's write that. 5 cents times 30 plus $22.50. Okay, and I don't have room to show you here, but if I did 5 cents times 30, that would give me $1.50, and then I would add that to the $22.50 that the cell phone costs. So that will give me 24. Okay, now my next input is 45 minutes from right here. So we're going to take the 45 times 5 cents. So we're going to do 5 cents times
Mr.
45
Blankenship, could you please
plus
call the office?
22.50. Okay, now when I multiply 5 cents times 45, that is going to give me 225, and 225 plus 22.50 is going to give me 24.75. And then finally, well, we have 1 hour, but we're talking about minutes because it's 5 cents per minute. So I have to convert that hours to minutes. And how many minutes are in an hour? 60. So we're going to do 5 cents times 60 plus 22.50. And 5 cents times 60 is going to be $3, and $3 plus 22.50 is 25.50. Okay, let's look at example number 2. Tim's salary as a lifeguard depends on the number of hours he works. Okay, so it's basically telling us what our independent dependent is there. If he is paid $9 an hour, what is his salary for 3 hours, 12 hours, and 22 hours? So they're telling us right off the bat that our salary depends on the number of hours. So salary is the dependent. And remember, that represents the y, and y equals mx plus b, even though we're going to use s for salary. And then the independent is the hours. And we're going to use h, but that represents the x, and y equals mx plus b. Okay, so let's write our y equals mx plus b because that's the form we want it to look like. And we know that the salary is going to replace the y, so s equals. And now we have $9 an hour. So we're going to take 9 times the number of hours. So we're going to say 9h. And that's it. We don't have anything else to add or subtract from that. So our equation is done. So our slope is the number in front of the x, or in this case, the number in front of the h, which is my independent variable. And so the slope here is 9. And the y-intercept is actually going to be 0 because this will pass through the origin. Okay, this is just a multiplication pattern. So it's proportional relationship, and it's going to pass through the origin. So now we have to write our rule up here. We have 9h. And our input is going to be our h, and our output is going to be our s, or salary. So our inputs are 3, 12, and 22. Let's go ahead and write those in. And now I'm going to plug it into the rule. So 9 times 3, and what's 9 times 3? 27. And now we're going to do 9 times 12, which is 108. And now we're going to do 9 times 22, which is 198. Okay, so what we're doing here is we're using our equation to figure out what a set of inputs equals to give us the output. Okay, so we're using our equation to find information. All right, let's go to number 3, which is up in the top right-hand corner here. The amount of money Sam has in his savings account depends upon the number of deposits he makes. Okay, so we've got, he currently has 75 in his account. Each deposit is shown below. Okay, so what we have to do here is we know that the amount of money Sam has in his savings account depends on the number of deposits. Okay, so the dependent variable is, we can call it total savings. That's how much money he has. And remember, the dependent represents the y, and y equals mx plus b. Hold on, that doesn't look like a y. Make yours look like a y. I'm having issues this morning. Okay, and the deposits are going to be my independent variable. And that's going to be representing x, and y equals mx plus b. So now let's write the equation, and I'm going to write y equals mx plus b under it. And we know that the total savings, so since we're talking about savings, let's just call it S. We could call it T, okay? I'm going to go with S. We have total savings. And then, now we need to see what we're doing here, okay? He currently has 75, so we're not doing anything with the 75, okay? So you got to look here, and we actually have to find the slope here because we have a table. It didn't tell us what we were doing to the independent variable. So look here. How do we get from 100 to 125? Good, plus 25. And how do we get from here to here? Plus 1. And if you look, plus 25, 1, plus 25, 1, plus 25, 1. So remember, slope is change in y over change in x. So we're going to do 25 divided by 1, which is 25. So that means I'm going to be multiplying the independent variable by 25. And in this case, it's the deposits. So we're going to multiply each deposit by 25. And then we have to add 75 because that's how much money Sam already has in his account. Okay, and I wrote it this way. Instead of doing 75 plus 25D, I wrote it this way to be consistent with mx plus b. So we know that the slope is 25 and the y-intercept, or the constant, is 75 because I'm doing that 75 every time no matter what. Okay, and this one already had the table, so we are good to go. We've done everything we needed to do. Okay, number 4. Is the price a function of the number of donuts? Okay, so let's see what we need to do here. Okay, and that means, is the price a function of the number of donuts here? That's basically saying, is it going to make a linear function? Is it going to make this line? But we wouldn't connect the line because we can't have a half a donut here. Okay, but it's going to follow a proportional relationship here. So that's what it's talking about here. So if it does, then we are going to write yes here. All right. So now we have our input is the number of donuts. So we know that that's the independent variable. So we're going to say donuts. We're going to use D in our equation. But remember, this is the x and y equals mx plus b. And that means the output is the dependent. And that's going to be the cost of the donuts. So we're going to say cost. And remember, that's y and y equals mx plus b. And so now let's write y equals mx plus b under here to help us out. And now we're going to take our costs. And look what we're missing here. Once again, we don't know the slope because I gave you the table instead of giving you the slope like I did over here. So now we have to find it. And the pattern is plus $1.25 and plus 1. And if you look here, it does that all the way through. So it doesn't change its pattern. So therefore, it is going to be a function. So you can write yes. Now our slope, hopefully you have room over here, is change in y over change in x. So we're going to do our output divided by our input. And that's just going to give me $1.25. So that's my slope. And we're going to take $1.25 times my independent variable, which is D. And guess what? That works every time because 125 times 1 is 125. So I know that there's no ending here. So it's a proportional relationship, which means the y-intercept or the constant is 0. Now let's look at our fifth and final example. Some plants need a large amount of space in order to grow. The number of seeds that can be planted in each row is related to the length of the row. Examine the table below. Okay, so our row length is going to be our independent variable, so let's just call it length. And that's going to represent x and y equals mx plus b. And our output is our dependent variable, and it says the number of seeds. So we'll say number of seeds, and that's going to represent y. Okay, so once again, y equals mx plus b. And since, once again, I have a table, I need to find the slope first. Okay, I should have been finding the slope, the table, before I started writing the equation in the other examples. Okay, so to get from 4 to 6, I go plus 2. And to get from 16 to 24 is plus 8. And I know it looks like the pattern changes here, but this is plus 7, and this is plus 28, which will give the same ratio of 2 to 8. And so will this one. This will be a 3 to 12 ratio, which will give the same one as 2 to 8. Okay? So this is change in y over change in x, which simplifies to 1/4. Okay? So the slope is 1/4. And let's see here. Look, is a fourth of 16 4? Yes. Is a fourth of 24 6? Yes. Is a fourth of 52 13? And is a fourth of 64 16? Yes. So that means the constant is going to be 0 because this is a proportional relationship. It's a multiplication pattern. We're multiplying by 1/4. So the equation is going to be y equals 1/4 x. Whoa, 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 sorry. I didn't use the correct letters. Whoa, stop, scratch that from your memory. The dependent variable is the number of seeds, so let's just call that n. And we're going to take the slope and we're going to multiply it by the length. So we'll use an L. Okay, now we have n equals 1/4 L. And if I plugged in all of these into this equation, it would give me the output, which is n. Okay, that concludes our notes